So guys, in this video we look at this integral, the integral from 0 to pi over 4 of x divided by the cosine square of x plus cosine of x times sine of x. So let's solve this integral by looking at the denominator again. This is the integral from 0 to pi over 4 of x divided by, I'm going to factorize cosine square of x out here, and I'll be left with 1 plus this one is sine of x over cosine of x. That is factorizing cosine square of x in the denominator. Now this one becomes what really? This is the integral from 0 to pi over 4 of x all over cosine square of x into 1 plus sine of x over cosine of x is the tangent of x dx. And 1 over cosine is secant. So 1 over cosine square of x is secant square of x. So this is the integral from 0 to pi over 4 of secant square x. So x in the numerator times secant square of x all over 1 plus the tangent of x dx. This is what our integral has been reduced to. And now we can do integration by parts, right? So the integration by parts, I'm going to do it here. D for differentiation and I for integration. I am going to integrate, differentiate x. So I have plus and next one is minus. Differentiating x is just 1. And I'm going to integrate the rest. The rest is secant square of x all over 1 plus the tangent of x, like this. So just do it here as rough work. So if you are integrating secant square of x dx all over 1 plus the tangent of x, you can do a u sub. You can let u to be equal to tan of x. So that implies that du is secant square of x dx. So you can replace secant square of x dx with du. And now you can take the integral from the x world into the u world. The numerator is now du all over 1 plus u. And integrating 1 plus u in the u world is the natural logarithm of 1 plus u. But what is u? U is the tangent of x. So you can just replace it. So this one, integrating this one is the natural logarithm of 1 plus the tangent of x. So that implies that integrating this, we are going to get the natural logarithm of 1 plus the tangent of x, like this. Cool. Now that we are done with this, now what we have to do is we have to multiply diagonal terms. That there's no integral, but when we multiply terms horizontally, we have to take the integral. So our integral now is what? So I is now multiplying diagonal terms. That is going to be x times the natural logarithm of 1 plus the tangent of x, the limits of integration from 0 to pi over 4, minus, that is this guy here, the integral from 0 to pi over 4. Because we are multiplying terms horizontally, we have 1 times the natural logarithm of 1 plus the tangent of x dx. Now let's simplify the limit, shall we? So the limits, you plug in pi over 4, you have pi over 4, the ln of 1 plus the tangent of pi over 4. Minus, if you plug in 0, everything becomes 0, because tangent of 0 is 0. We have the natural logarithm of 1, which is 0, times 0 here, which is 0. So the lower limit evaluates to 0, minus the integral from 0 to pi over 4 of the ln of 1 plus the tangent of x dx, like this. So I is tangent of pi over 4 is tangent of 45, which is 1. And I have 1 plus 1 here, which is 2. So we have the ln of 2. So this one simplifies to pi over 4, the ln of 2, minus the integral from 0 to pi over 4 of the ln of 1 plus the tangent of x dx. So the task now is to find the value of this integral. Once we get the value of that integral, we just subtract that from pi over 4 ln of 2, and then we'll get the resulting value of our integral I. So now let's deal with this one in yellow pen. So I'm going to call this integral I1. So I1 is the integral from 0 to pi over 4 of the ln of 1 plus the tangent of x dx. So this one I am going to use the King's rule, right, which says that the integral from a to b of f of x dx is the same as the integral from a to b of f of a plus b minus x dx. This is the King's property, right? So what is a plus b minus x in this integral? So a plus b minus x here, a plus b minus x here is going to be equal to 0 plus pi over 4 minus x, which is pi over 4 minus x. So we're just going to plug pi over 4 minus x in place of x in this integral. So the integral I1 transformed by the King's property is the integral from 0 to pi over 4 of the ln of 1 plus the tangent of pi over 4 minus x, like this, and then dx. And we know that tangent of, if we have tangent of pi over 4 minus x, this one can be written as the tangent of pi over 4 minus the tangent of x all over 1 plus the tangent of pi over 4 and times the tangent of x. This is how tangent of pi over 4 can be simplified. So the tangent of pi over 4 minus x can be written as tangent of pi over 4 is 1, that's tan 45, minus tan of x divided by 1 plus tan of x. So in place of tan of pi over 4 minus x, I'm just going to replace it with this guy. Okay, so the integral is now I1 equal to the integral from 0 to pi over 4 of the ln of 1 plus this guy, which is 1 minus the tangent of x all over 1 plus the tangent of x dx. Cool. I1 is the integral from 0 to pi over 4 of the ln of, we can now multiply in with this guy, which is 1 plus the tangent of x plus 1 minus the tangent of x, all divided by 1 plus the tangent of x dx. So this cancels this, and then we have I1 to be equal to the integral from 0 to pi over 4 of ln, and this is now of 1 plus 1, which is 2 all over 1 plus the tangent of x dx. And using the laws of logarithm, this one becomes the integral from 0 to pi over 4 of the ln of 2 minus the ln of 1 plus the tangent of x, all this one dx. That is using the laws of logarithm. You can now split this integral into two different integrals. The integral from 0 to pi over 4 of the ln of 2 dx minus the integral from 0 to pi over 4 of the ln of 1 plus the tangent of x dx. These are now two different integrals. But what is this integral? This integral is the same as I. That is our original integral, I1, I'm sorry. This is the same as I1 originally. So you can just go back down here and replace this one with I1. So this is I1 to be equal to the integral from 0 to pi over 4 of ln of 2 dx minus this one is I1. You can add I1 to both sides. We have 2I1 to be equal to, integrating this one is the ln of 2x. Limits of integration from 0 to pi over 4. You have 2I1 to be equal to ln of 2 multiplied by pi over 4 minus 0. And that is equals to pi over 4 times the ln of 2. So you can divide both sides by 2, and then we have I1. This cancels that, and then we have I1 to be equal to pi over 4 ln of 2 multiplied by 1 over 2, which is pi over 8 times the ln of 2. Now I1 evaluates to pi over 8 ln of 2. Now we can go back up here and now wrap up the integral. So the integral, we know that I is pi over 2 ln of 2 minus I1. that is I, our integral. So I here is pi over 2 ln of 2 is pi over 4. So pi over 4 ln of 2 minus I1, and the value of I1 has been found. So I is equal to pi over 4 ln of 2 minus pi over 8 ln of 2. And that simplifies to, we can factorize pi ln of 2 out. And what we are left here is 1 over 4 minus 1 over 8. And that is equals to 1 over 8. So that is pi ln of 2 times 1 over 8, which is pi over 8 ln of 2. Therefore, the value of I is pi over 8 times the ln of 2. This one is the answer to our integral. So when we go back up to the very top, this integral evaluates to pi over 8, the ln of 2. I get to see the King's property and integration by parts. So this is how I can solve this integral. If you have an easier way of solving this integral, please leave a comment in the comment section. I thank you so much for watching this video. Please subscribe to Calculus Diaries for more engaging content, and I will see you in the next one. Bye bye.